Exercise 16 is your last lab assignment. Here you are going to look at a complete urinalysis, and the objective is to critically analyze the role of the complete urinalysis in diagnosing urinary tract infections. Urine is the most commonly analyzed body fluid in the lab, and it can give us great clues as to a person's health and well-being. So for this assignment, you're going to consider the following results from a culture and sensitivity. Sheila Langdon's urine was sent to the laboratory for a clean catch midstream urine culture. This is called a culture and sensitivity. The bacteria, the urine will be cultured, and if necessary, a sensitivity or an antibiotic susceptibility test will be completed. Her culture results came back as greater than 100,000 colony-forming units per milliliter, the bacteria identified as Escherichia coli. Now, taking a look at these results, does this woman have a urinary tract infection? How do you know if she does or if she doesn't? Now we're going to step back in time, let's say 24 to 48 hours, when Sheila collected her urine. Remember, the urine culture and sensitivity results take a minimum of 24 hours after the specimen reaches the lab. So we're going to consider what would her complete urinalysis have looked like on that urine that was brought into the lab or brought into the doctor on that day. A couple of things we have to remember before we take a look at the assignment, and that's what the normal values would be for a complete urinalysis. With the physical analysis, usually the urine is pale yellow to amber color. There are a wide variety of colors that we see. We also would expect it to be clear, having no turbidity. In the chemical analysis, or the dip strip, we have most values being negative, with the exception of specific gravity, which is 1.003 to 1.030. Note that there are no units associated with specific gravity. The pH can vary widely from pH 6 to pH 8. Urobilinogen is normal at values up to 1 milligram, or EU, per deciliter. The rest of the values are negative for a normal urine. Microscopically, we shouldn't find any casts in the urine at the low power field other than hyaline casts. All other casts are considered pathologic. Epithelial cells are quite common, especially in women. They are not considered pathologic, and epithelial cells typically are counted and averaged per low power field. In other words, the technician would take a look at 10 different fields, count up how many epithelial cells he or she saw, divide by 10, and that would be the average per low power field. Red blood cells and white blood cells can be present in the urine. Anywhere from 0 to 3 per high power field would be considered normal. Anything over 3 would be considered abnormal. The higher the leukocyte esterase, for example, on the strip, the more white blood cells you would expect to see in the urine. For microorganisms, we don't expect to find any. They are identified to the extent that can be accomplished with a wet mount. For example, you wouldn't be able to look at this urine and figure out that these were Escherichia coli because there are many rod-shaped bacteria, but you could identify them as a bacillus and perhaps even identify them as being motile. Or you might see cocci. Perhaps you might see yeast in the urine. You wouldn't know if that yeast was Candida or Saccharomyces or Rhodotorula, but you could identify it as a yeast. Crystals are usually only reported when they are abnormal. They are identified, counted, just like epithelial cells would be, or white blood cells would be, and averaged, reported per high power field. Artifacts such as oil droplets, talc, granules, fiber, hairs, for example, they typically are not reported. So let's take a look at Ms. Langdon's results and think about what the lab might have seen in her complete urinalysis. Based upon your activities in lab, imagine 24 to 48 hours before the culture was reported. What would her urine look like? Does she have a urinary tract infection? So what do you think her urine would look like with a urinary tract infection? Normal colors or colorless, pale, yellow, dark yellow and amber, but abnormal colors are pink, red, brown, green, and orange. Turbidity is often rated as clear, 1+, 2+, 3+, or 4+. Some laboratories will use terminology such as clear, slightly turbid, turbid, or flocculent. Flocculent looks like there are chunks of snow floating around in there. The important thing to remember is that all three components of the urinalysis have to correlate. If the urine is turbid, there's a reason, and you're going to pick up that reason either in the chemical urinalysis or in the microscopic urinalysis. The same thing with an amber-colored urine or a red-colored urine. There is a reason, and it is going to show up in another component of the urinalysis. The chemical analysis is to be considered next. Think about what values are normal and what values would be abnormal in a person with a urinary tract infections. These things were addressed in lab and written on the board, so go back to take a look at your notes and think about what we might have seen in Ms. Langdon's urine, considering the high number of Escherichia coli found in her urine. The values should be reported as they are seen on the multi-sticks test strip. If there is a unit reported, then it should be included in the result. Again, remember all three parts of the urinalysis must correlate. So if you had a pink urine, that means there was blood in it. So the blood should be showing up in this chemical analysis. Remember that blood also is reported as hemolyzed or non-hemolyzed. Take a look at the strip or the values on the side of the container, and you'll see that they are given for hemolyzed and non-hemolyzed. Consider this when you are doing the microscopic analysis. If the red blood cells have hemolyzed, that means they've popped open, and you're not going to see them, or you'll see fewer of them on the microscopic urinalysis. However, if they are non-hemolyzed, you're going to see them intact when you look at the sediment under the microscope. Finally is the microscopic analysis. So think about what the urine sediment would have looked like on the day it was collected, before the culture results were in. Remember to include the magnification. That's what we mean by number per field. HPF is high power field. LPF is low power field. Epithelial cells, red blood cells, and white blood cells are usually reported as average number per field. But microorganisms aren't counted. It would take far too long to count 10 fields, and microorganisms are very often modal, so it's difficult to count them. So typically they are going to be reported as none, few, moderate, or many. You'll need high power field in order to view bacteria because of their size. Again, remember that the microscopic analysis has to correlate with the chemical analysis and the physical analysis. Good luck with this assignment. It's your last one. Let me know if you have any questions.